Hey everyone, now that we know what we need to know about t-scores, we're going to be talking about the better version of confidence intervals. So let's get started. Now this may seem off topic, but I want to remind you that this class is called statistics, not parameters. Now that implies that we don't know about population standard deviations, but we can find the standard deviation of our samples. Now we're going to go over to the computer and take a look at how you should create confidence intervals. So see you guys there.
All right, so this confidence interval is the one that I want you to know how to use because it's mathematically correct to use whenever you have a sample. And I'm going to explain why that is in a moment here, but let's go over the formula first. So first we take our the center of our confidence interval, which is the sample average. And again, I know I'm using different letters here. Normally I use mu for mean, but in this case I have a sample mean, which is a little different. This is a sample average. Again, we use a sample average because whenever we do an experiment or a test, we use a sample. We use the statistics, not the parameters. We don't talk about the population because we're not measuring the population. We're measuring a sample. So we're only going to have the sample average, and so that we use the sample average here, and then we're going to add plus or minus, and this is going to be our margin of error. So we have our center of our confidence interval, and we're going to add some margin of error on both sides, which is why we're doing a plus or minus here. And then instead of z star or z scores, we're going to actually use t star. And it's going to be denoted like that. And that star is not like a multiplication sign. It's like a name. So t star in and of itself is like just whatever t-score you use, depending on what type of confidence interval we use, and depending on your sample size. And then we multiply by our standard deviation. Now, our standard deviation is dependent on your sample size. So again, we divide by the square root of n. But our numerator is not going to be the population standard deviation because if you remember, we can't calculate that. It's not possible to calculate the population standard deviation. But we can calculate the sample standard deviation, which is denoted by sigma with a little s here. And so it's important to understand that because we have this right here, that's not quite the population standard deviation. So I'm assuming that is the same as the population standard deviation, but the chances are that it's not. And because of that possibility of error, t star is what we need to use to accommodate for that error. And so that's why t star is used instead of z star. And that's also why t star is greater than z star, because if this number is bigger, then the margin of error as a whole, which, by the way, I'm going to circle the margin of error. This whole thing right here is the margin of error. That whole thing is bigger because t star is bigger. And so it's important to understand why we use t star instead of instead of a z star. So let's go over an example of this. All right, so now we're going to work with a concrete example of using a confidence interval, the good version of confidence interval. So I'm going to give you guys some data. And this is typically what you're going to have when you do an experiment. You're not going to have a bunch of random statistics just freely given to you. You have to calculate all of those. So let's say you gather some heights. So here are some heights. And these are in inches. So we have, let's say, 63 inches, 70 inches, 65 inches, and let's do 65 a little better there. 65 inches and 72 inches. And let's do one more, 73 inches. All right, so this is the data that we collected. And if you notice, we have only 5 observations here, which is not a lot. So our penalty should be pretty hefty here. We're going to create a 95% confidence interval. So I'm going to write the formula here in a second, but first off, I need a couple things. I need to calculate t star. I need, what else do I need? I need my average, my sample average, the average of those 5 numbers, and I need the sample standard deviation. So the cool thing is that my sample average and sample standard deviation can all be calculated using either like some sort of calculator, or you can go online and find a calculator. So we're going to go online together to calculate all of these things. All right, here we go. So first off, we're doing a 95% confidence interval. So I'm going to scroll all the way down, and if you notice, right here it says 95%. So we're going to be using specifically that column. We're going to ignore the rest of the t-table because that's the confidence interval we're going to be working with. So now what I'm going to do is I'm going to make some annotations on the screen over here. So let me pull up my notepad. All right, so we have n equals 5. That's the number of observations in our study. We only had 5 numbers, if you remember. So because n equals 5, and degrees of freedom is always calculated by taking that n and subtracting 1. Again, don't ask me why we do this. Like, I think it would be much better if they put n right here, but maybe that's just because of my ignorance of statistics. So in this case, df is 5 minus 1, which is 4. So we're looking at df equals 4, which is right there. And we're also doing this column. So if you scroll down, you'll be able to recognize that this is the column that we're using. So let's see here. Our t star is 2.776. So it's important to understand that if we use a 95% confidence interval, we would have done the z star would have been 1.96. But we're using 2.776, which is a little bit larger. It's actually a lot larger relative to the size of 1.96. That's like almost a 50% increase. And so that's going to increase the margin of error by like 50% just because our sample is so small. So let me go over to those annotations. Or let me go over to our notes and let's fill in 2.776 for our t star. And now we have to calculate the sample average. So to do this, we can just add up all the numbers and divide by 5. I believe I have a calculator over here. Good. Now, if you want, you can find a tutorial online on how to do this, but you can actually just hit Stat and then hit Edit. And then you have a bunch of lists. We're going to deal with list 1, but it doesn't really matter which list you deal with or you work with. But I'm going to use list 1. So list 1, the way I'm going to do is I'm going to enter in those 5 numbers that you see over there. 63 is going to be the first number, enter. 70 is the next number, enter. 65, enter. 72, enter. 73, enter. So I have 5 numbers on list 1. It says L1 on that column. It's kind of hard to see maybe, but we have L1 with 5 numbers. Now I'm going to hit second mode to quit, and we should be at our home page. Now with the TI-84, what I'm going to do is I'm going to hit Stat, and then there's a menu at the top here. There are 3 tabs here. There's Edit, Calc, and Tests. We're going to go over to Calc, and we're going to calculate the one variable statistics, and then it's going to ask me for L1. The answer is yeah, I want L1, and then it actually gives me all the statistics of that list. In particular, it gives me the sample average, which is SX. Sample average is going to be 4. Yeah, that's definitely not right. That's the standard deviation. Sorry, guys. SX is the standard deviation, but X bar is the sample average. So sample average is 68.6, and the sample standard deviation is 4.39. So now we have everything we need. Now we just need to put everything together in the formula for developing a 95% confidence interval. So what we're going to put here, and I'm going to use a different color to make things a little bit fancier, 68.6 plus or minus t star, which is 2.776, times the numerator is going to be my sample standard deviation, which is 4.39, and my denominator is going to be the square root of n. How many observations do we have? We have 5. So now we just need to figure out what that interval is. So there's a low number and a high number depending on whether or not we use a plus or a minus. If we use a minus, we get the low number. If we use a plus, we get the high number. So now let's see here. I'm going to first figure out what my margin of error is. And this is actually what I would do in general, is if you calculate the margin of error, you avoid the PEMDAS issue that your calculator is going to have. So I'm going to do the margin of error first, 2.776 times 4.39 divided by the square root of 5. And I get a margin of error of 4.45. So now I need to add that number and subtract that number from 68.6. So 68.6 plus 5.45 is 74.05. That's the bigger number. And then the smaller number is what I would get if I subtracted 5.45, which is 63.15. And that right there is my confidence interval. So let me explain what this confidence interval means again, because this is really, really important. I don't want you to just memorize some procedures. I want you to understand what the confidence interval is useful for. So the idea is we have these 5 numbers, and we're trying to figure out what's the average height of our population. So we sampled a certain population, whatever that population is. This is what we know about the population. There is a 95% chance, so that's what this number comes in, 95% chance that the average height is somewhere between 63.15 inches and 74.05 inches. So the idea is we now have an idea where that average height is. We have a good idea too. It's 95% accuracy. So we could be wrong. The actual average height could be outside, but based on the way these heights are looking and how spread out they are, and because our sample size is relatively low, we get a confidence interval from 63.15 to 74.15. So I hope this helps everyone. Thank you guys so much, and I'll see you in the next lecture.
You just watched a video from Amore Learning. We provide free math videos, and we offer many online courses. We also provide free math tutoring via YouTube Live every Thursday and Sunday at 9 p.m. Eastern Time. Make sure to subscribe to our YouTube channel and like this video to get access to all of our free content. And put a comment in the comment section if you have any math questions. Check out all of our courses on amorelearning.org.